In a clinical trial, 21 out of 650 patients taking a prescription drug complained of flu-like symptoms. Suppose that it is known that 2.5% of patients taking competing drugs complain of flu-like symptoms. Is there sufficient evidence to conclude that more than 2.5% of this drug users experience flu-like symptoms as a side effect at the alpha equals 0.01 level of significance? So first we want to write down our null and alternative hypotheses. So we have H sub 0 and H1, and then our colons, and we're looking at a proportion. So we have P, and then the null at this point in this class is equal to. And then the alternative, we want more than, so greater than. And then 2.5%, we want to write that as a decimal, so 0.025. And then we would want to verify our conditions here. So n times p naught times 1 minus p naught is greater than or equal to 10. That we have a simple random sample. And either n is less than or equal to 5% of capital N, so our sample size is less than 5% of the population, or we have that our sampled values are independent. So I would say that we can reasonably assume that we're working with a simple random sample and that our sampled values are independent, or we're probably talking about a nation here, or patients taking a prescription drug here. That's probably 650 is less than 5% of our population here. So we just need to verify this condition here. So N is 650 times 0.025 times the quantity 1 minus 0.025. So we have 650 times, in parentheses, 0.025, close parenthesis, open parenthesis, 1 minus 0.025, close parenthesis. We get 15.84375. So we get 15.84375. So that's greater than or equal to 10. So now we want to look at computing the p-value. So we're going to proportion stats, one sample with summary. So our number of successes is 21. We have 650 observations. And our null is that p is equal to 0.025. Alternative is that p is greater than 0.025. And we're going to hit compute here. So our p-value is 0.1164. We want to round to 3 decimal places. So this is approximately 0.116. So we want to compare our p-value to alpha. Alpha is 0.01. Our p-value is greater than alpha. So the p-value is greater than alpha. We do not reject the null hypothesis. And that means that there is insufficient evidence to conclude the alternative, right? So since the p-value is greater than alpha, this is less than alpha, this one's less than alpha, so we can eliminate B and C. Then we do not reject, so do not reject, just one. And we conclude that there is not sufficient evidence that more than 2.5% of the users experience flu-like symptoms at the alpha equals 0.01 level of significance, right? I'm going to add that little bit there. Right? Because if our level of significance changed, then our result might change there.